Hey, what's going on, everybody? Today is February 8th, and you are listening and watching the Daily AI Show live. And today we're talking all about vector embeddings and semantic search. And we have with us Jyunmi, Beth, Andy, Karl, and I'm Brian. So we've talked about vector embeddings before on the show, but now we're at, I think today's episode 134. So we wanted to sort of bring it back around and talk more about what they are, why they're important, how they relate to semantic search, where is semantic search being used? I think there's some thoughts thinking like, oh, Google just started using it. And truth be told, Google has been using some version of it since like 2013. So it's not necessarily new, but it is getting a lot of airplay right now. A lot of people talking about it because of these new advancements in AI. So with that said, I don't know, Karl, do you want to kick us off with maybe some basic understandings of what a vector embedding is as far as the math side of things?
Yeah. And you can go really complex into this, but I think let's start with three big terms, right? You got vectors, you got embeddings, and then you also have, you've got indexing. Actually, no, maybe not three big terms. Maybe maybe 4 or 5. And you've got indexing. So let's start with those three first. And I'll use an analogy to kind of explain it. So imagine vectors. Think of them as arrows pointing in a specific direction. Now that arrow could be this small, this big, really big, like it's however big. And these arrows really represent anything from words, items, concepts, right? So it could be a phrase, could be one word, 2 word, like a sentence. Now, let's talk about embeddings. Now, imagine if we can describe every word, item, or concept and its relation to other words, items, or concepts. So that's what it means by embeddings, a way to represent words or items as vectors in a space. Probably a more simple way to do it is I'll explain how, let's say, a custom AI chatbot takes your data and turns that data into a way that could be quote unquote read and retrieved by a large language model. So let's say, simple example, a PDF. PDF has paragraphs, words, sentences, some charts to it too. And what happens is that PDF is what's called chunked. Think of it as just broken apart into however the amount you've set or the custom AI chatbot has set, right? Could be 2,000, 1,000 chunks, 500 chunks, but it needs to be chunked because a large language model only has certain, like a context window, they can only read so many things at once. So it has to be chunked in, especially large amounts of PDFs. We're talking like hundreds of documents. Now, each of those chunks and the words and concepts get turned into what's called embeddings in what's called a vector database. And effectively, it turns into numbers. So, or number representations. So let's take the word Komodo dragon. That could be 0.66444412. And then the word pet could be 0.77144. And what the large language model is trying to do in that vector embedding, the vector database, is to figure out the relationship between, again, words, concepts, and ideas. And that's where we're talking about semantic search. So a Komodo dragon would be closer in a numerical representation to a pet, but a dog would be even closer. And an alligator would be much farther. But because in the history of humanity, there are people who have kept alligators as pets, that would still be closer than a hippopotamus. So those are just the relationships between words. And that's essentially what a vector embedding is.
So
Now,
can I throw one thing into the real
sure.
quick, Karl, before you move on? Because I think this is important. Like where I got tripped up, so this is more from my learning, was it's easy to conceptualize four quadrants on a piece of paper,
Mhm.
and X and Y of five each is significantly and mathematically distant from negative X of -5 and a Y of -5. One's in the upper right, one's in the lower left quadrant. We can conceptualize that without even seeing a piece of paper. As humans, it's pretty easy, even easier to like, or just as easy to throw a z-axis on there, and now we're looking at a cube of a graph,
Mhm.
and we can say, okay, these things are sitting in space over here, and these words are in space over here. What is the leap that we need to make for vector embeddings is that there are not just one, two, three, five, or 10 dimensions. There's hundreds or thousands of them,
Thousands of dimensions.
right? Or thousands. So a word like Komodo dragon and pet may be significantly similar because they have essentially what looks like a longitude and latitude type number associated to them, but they're in multiple dimensions at once at one time, and so they may also be significantly relevant to a word like mammal or cold-blooded or reptile or whatever, right? Because they also have meanings and connections to that as well. So we can kind of go as far as maybe three, maybe we can sort of get to a fourth dimension and think, okay, what would that look like? We're talking about thousands of dimensions and mathematical points within thousands of those dimensions. So any given word, to your point, or document or whatever, may sit in this sort of blob, right? That's hard to understand. But
So
anyway, that's the way it kind of worked in my head. Do I have that right?
you do, and that's what the next thing I was going to get to, right? Because like
Perfect.
immediately when we think of what a lot of people, when I say Komodo dragon pet dog, you think of 2D on a piece of paper, and you're probably drawing it out in your minds like, oh, there's a pet, that's a numerical representation of 0.666 whatever. Oh, here's an alligator, 0.67. But it's like it's not in 2D, it's not even in 3D, it's not even in 4D, right? It's
Right.
1312D.
Yeah.
And that's essentially how a computer goes in and looks at all the relationships of these vectors and what's close together. So when you ask a question, it looks into, okay, what is the relationship between the question or the topic or the concepts of the words into what is in my database. And then it looks at that, combines that with your large language model, and gives you the answer. Now, where it runs into an issue at the moment in a lot of vector databases is it's easy with what's the term called? Unstructured data. That means words and videos and even images. Where it runs into problems is structured data, because structured data, like an Excel spreadsheet, there is a right order. It's not just words and paragraphs. There is a specific order that you've created, let's say that Excel spreadsheet, that columns and rows. So when you chunk it, break it apart and give it representations, how does a vector database know that it's supposed to be in a specific order? So it can't just start
Right.
pulling random things. Now they have made advances on those, and that's where I'm pretty impressed with the OpenAI's vector database versus anything other vector databases like Chroma, Pinecone, and other things that people have used or businesses have used, because for some reason, and it could be the amount of the way that it's been chunked, or more importantly, how many dimensions there is, because the more dimensions, the more opportunity it is to search through it. I don't know what it is, but OpenAI's vector database seems to be much better at retrieving data and getting insights from that data than it is anything that I've ever worked on. Yeah, and really that's, you can, there are, when you talk about indexing your chunks, there's different techniques. Like We can go into tree-based structures, hashing, graph-based. There's a lot of different ways. I think the most important part to know about indexing is that's where a computer is actually, or machine learning is actually breaking apart and providing those numbers to your data.
And the reason, if I understand correctly, the reason that this is important is because the function that we talk about as hallucination is impacted by where things are and what would be most likely. And if you have things that are chunked that you want actually retrieved in a specific, like this is the right thing, that's how this comes into play. Is that true?
Yes, and Andy,
Ish.
you raised a really good point about that in our previous conversation, because you mentioned that, like, oh, so how does it know that an alligator is closer to a pet than or sorry,
A hippopotamus.
than a hippopotamus?
Yeah.
But a dog is closer to a pet. Well, it's like a large language model. Like, a computer analyzes like millions of text to learn these relationships, especially in natural language processing, to see how those words are used in sentences, how those concepts are used in those concepts. And so there's like the two that I've learned are, there's machine learning models. It's already being used too in our search engines when we actually, are looking for something. So BERTs, there's dimensionality reduction. So if you think about it, things like Google and Bing have already been doing this, finding the connections between words. But now you just take it even further, because it isn't just finding connections, it's answering the question that makes sense to what what's been asked. And that's why, like, a large language model by itself, even though it's pre-trained on all this data, will have hallucinations. But if you provide it more context, hence vector embeddings, because now it's very focused on specific set of data, it reduces the likelihood, reduces the amount of hallucinations. Doesn't completely take it out, but now it has more context and more data related to it, specifically your data that maybe it was never trained on.
Yeah,
And this is a good example too.
Let me just comment on why database is useful in the context of a large language model like GPT-4, or now Gemini Ultra, Gemini Advanced, it's been renamed. Why that's important, and it's related to what you just said, and that is that there's a lot of information that's sort of distilled and contained in the enormous training data that's now got a representation in this deep neural network that is the GPT. The issue is that you don't want to just simply rely on that corpus of data that's been pre-trained. You, as a company, for example, might have very specific data that wasn't part of the training set. And you want your large language model to be able to look at all of your data, and you don't want it, and use that data primarily so that it doesn't make stuff up based on its sort of more generalized training. So that's the issue around hallucination. So I have this database. Pinecone is a vector database. Chroma is another one. And there's also another alternative, which is called a knowledge graph, which has structure to it. You referenced this earlier, Karl, that you actually can have a database that's used in RAG, or retrieval augmented generation, that has structure built into it. They have nodes and relationships, edges to other nodes, and it's like a taxonomy of all this information. So it has structure. And this goes back to your question about, or your comment about having a spreadsheet which has structure. Oh, this column represents this attribute of this data. And so, it has an organization already inherent in it. A knowledge graph does have that. Neo4j is one knowledge graph database that is used in artificial intelligence applications, including large language models. Going back to the whole issue of why this is important is, Now you've got this company that's putting this database alongside an LLM with their own proprietary data, but the database is enormous. You can't feed the LLM the entire database every time. So what you have to do is be very selective. And vector database is a method using unstructured data, but vectorizing it so that you have similarity search. So that what I do is if I make a query to the LLM that's powered not only by the underlying foundation model's training, but also it has access to this database. You take the question that I asked it, you embed that. You translate that into embeddings, the mathematical representation, and you put it against the vector database in a vector search that finds those mathematical representations of passages and documents that have a similarity to what the question was. And then you bring only those documents over and you assemble those documents that are relevant, similar to the question, and you add those as context in the time, at the very time that you're asking the question. So it's an efficiency question to a large degree that RAG, or retrieval augmented generation, is being used primarily now as the foundation for specific knowledge being incorporated into large language model interactions.
And just to give like a familiar concept to understand this, as people playing with images on the internet, we're fairly familiar with the difference between a vector image, a vectorized image, and a pixelized image, right? A regular image. Pixel images, if you blow it up, you get furry, right? Because it's pixelated, because each place in that is just represented as its own state. In the vector, it's represented in a relationship, and vector images are smaller, right? Because what they're telling you is the relationship between all of the pieces that make up the image rather than the state. And that's what's happening at a much larger level in this, but it is familiar to something that we have.
Yeah, it makes them infinitely scalable. I mean, you can take an image that's vectorized and put it on the side of when you go past stadiums and you see some of the main football players, and their giant pictures are on the side of the football stadium. That has to be vectorized. It's a 40-foot by 100-foot image, or something.
But the relationships between the pieces in it remain the same, right? Yeah. It's true. It also has this. Karl, were you going to correct me?
There's one thing that I like to think about this, and it's a funny way to think about it. Has anyone here watched the Doctor Strange multiverse movie? Has anyone seen that?
Oh, yeah.
So I like to think of each of these vector databases having essentially a Doctor Strange in it, and you have provided Doctor Strange with data that Doctor Strange will put into multiverses, because how many dimensions, right? He puts it into all sorts of multiverses. And when you want to find your data, said Doctor Strange will go out into these multiverses and pick up essentially libraries in these multiverses and pick them out. Now, some vector databases are better than others. So, for example, I would consider OpenAI's having actually the real Doctor Strange. But in another vector database, you could have someone like, I don't know, Spider-Man. Not really as good as Doctor Strange pulling up your data. Maybe decent. I don't know. But it may be better than us. I would prefer a more closer representation to Doctor Strange than someone like Spider-Man, who could mess everything up. And then you could get all over the place with do you really want Thor doing your thing? I'm not sure, but I'd still prefer understanding and that's how I see certain vector databases. You're like, what happened here? This is the way that essentially that person has organized your data maybe isn't the best way to organize it. And I feel there'll be better and better ways to organize your data, so it'll be even more accurate in the future. And I'm hoping with agents that You don't have to necessarily put the data in a database. You will just give instructions to said agents, and then you'll have, I don't know, agents of S.H.I.E.L.D., Hydra, taking data and putting it into these multiverses. Although with Hydra, you do it for malicious reasons, and S.H.I.E.L.D., you would do it for good reasons. That's how, like, to me, that's how I would start seeing these
That's
things.
good.
I love it.
That's a great
Very
analogy. I love that,
enjoyable. I
Karl.
like
The
that.
Marvel universe of vector embeddings. I wanted to say earlier, when Beth, you were saying a good, easy, bring it back down to earth type example, and I didn't think of this. I read this. I didn't come up with this. Was that what we would call few shot or one shot or zero shot prompting, which is just to say giving it an example. It's just a fancy way of saying giving an example is in fact an idea of vector embedding, because what you're essentially doing, back to what you were saying, Andy, instead of this massive monumental database of proprietary knowledge that I append to the LLM, really what I'm saying in a simple prompt is, hey, I want you to go out and write this email, but hey, don't just write any email. Your email has to look as similar to this example as possible. This is what a good email actually looks like to me, right? I mean, it may be different to everybody. So I want you to, look like this, or a voice paragraph, which is to say, I'm not a huge fan of voice paragraphs, but the idea is that this is the style tone of Brian talking, yada, yada, yada. These are all the bits and parts of what makes me when I talk, my intonations and things like that. And that goes into a paragraph. And then I take that paragraph as a variable and I put it into my prompts so that I'm like, hey, in this case, I needed to come back sounding more like me. Oftentimes I find that just a couple examples of writing will take care of that. So I deal a lot with LinkedIn strategy. I deal a lot with writing LinkedIn posts. And when you use AI, this is something you have to definitely factor in. I just never really thought of it as actually being part of what we would consider to be vector embedding. But it's a cool concept. It's a very, very basic starter concept of, oh, I gave it this example. And what is the model doing with this example that I just provided to it in order to bring me back even more personalized answers?
Right.
Does that work? Does that work?
Mm-hmm.
So the structures also that we talk about, right? It's a good idea to give it a role. That limits, right? So you're going to talk to me as a life coach. You're going to talk to me as like a 5-year-old, or you're going to talk to me as an improviser trained at UCB, right? Like you're going to have some context in which that's also limiting the amount of information that it's looking for, because it's only looking for the information that is whatever within this level of closeness, right? Wow. Okay. We've been doing this the whole time.
Yeah, exactly. That was kind of my sort of take on it.
There's a couple of side points I just want to throw in there. One is that the embedding process, there are embedding codes, right? One of the most popular is called ADA-002, and it uses 1,536 dimensions. So it translates words or phrases, whatever chunk you give it. You can give it a full sentence. Your chunking process can say, okay, I want you to look at sentences in this particular document, or I want it to be chunked into smaller portions, like even partial words. That's sometimes happening, because if you've got supercalifragilisticexpialidocious, it's going to get broken up into subsegments of that sort of thing. So that's one thing. The other point I wanted to make is that when you make a query to a large language model that has a knowledge base that's associated with it, many chatbots that we've deployed do, we upload documents from the company that are then used as additional context, but using a vector database and a vector search, a similarity search to bring them back. You don't know. There's nothing that shows what documents were actually added to context unless you can look behind the scenes in the LLM and see what the compiled prompt was. Because everything that you say in your question, plus all the system prompt and other instructions, are assembled and sent to the LLM at the same time. So if you were able to kind of pierce the veil and go in behind and see, okay, well, which documents did you actually bring up when I asked this particular question? That kind of tuning can help the other code that's built into that vector search routine to improve the performance of the vector database. And that's why I think, Karl, you're experiencing OpenAI's as being more effective, even though it's probably the embeddings in another alternative model or another platform that uses a chatbot and has a knowledge base with it that's embeddings. They may have a very similar structure in the embedded vector space, but there's other routines that are being applied to ensure the relevance of documents that are brought forward from such a knowledge base.
So, Brian, you raise a really good point about providing examples, because the one thing that I've found the difference between OpenAI's vector embeddings versus others is if you have a very long list, and this is usually my test. When I say long list, to say like, let's say 10 points, and of those 10 points, 5 of the points have subpoints, 3, 6, 7 subpoints. So you have a really long list with a bunch of points and subpoints. I found with a lot of embeddings or vector databases, it'll only provide back 5, 6, say, of the original points. It wouldn't fill out the entire 10, 15 points. And it was only until I actually provided examples and say, I need you to fill out like this, that it actually said, oh, sure, no problems. With OpenAI, didn't need to do that. It would the entire list, no problems. So I was like, I'm kind of wondering why that was. Like, why does OpenAI's vectors embeddings give the full list versus Pinecone?
Karl, I think it could be in part the more advanced reasoning capability and instruction tuning that OpenAI has developed, not anything to do with the knowledge base that's being used in OpenAI. I want to clarify that when Karl talks about OpenAI's vector embeddings, he's talking about the knowledge that you can add to an assistant API in the platform, or in a custom GPT, you can add knowledge documents. And then without you having to do anything, there is a vector database that's being used against those documents that you've uploaded. Now, I can also use Pinecone with OpenAI. I can use ChatGPT-4 with Pinecone, which is a totally different one. And there's an interface between those two, like in the vector search, that will have a slightly different result from the one that's using the specific platform that Karl's referring to within Assistant API or in custom GPTs.
Yeah, the one difference, and it's really worth reading Nick Dobos's comment, his X post on this, is I do believe, and I've been testing this for about a week now, that a custom AI chatbot using Pinecone, or I would say things like a Chatbase or Retune or a Dante, doesn't use your embeddings, or sorry, not embeddings, your files as part of the context. And that was a really good point, where if you uploaded, let's say, 3 or 4 documents into, say, a custom GPT or an assistance GPT, it uses those, if it's a PDF or a .txt file, as part of the overall context and prompt window, versus something like a Dante or Chatbase. It actually separates and makes sure it retrieves that data. And so it's a very good point that if you upload things into, and this is the big difference to me, if you upload things into OpenAI's, let's say, custom GPT or assistance API, it becomes part of the overall prompt, versus Dante or Chatbase, where it isn't part of the prompt. It's separate. So,
and yet you're saying that method that OpenAI uses for those particular implementations is preferable. It actually works better. That's why I think it might be more about the instruction tuning.
It could be more about the instructions, but it gets to a point where it starts losing, or you don't get the most. If you have a lot of data,
Yeah, it'll cloud the
Clouding
reasoning. Yeah.
versus
So
Right.
that's why vector search, similarity search, and refining the additional context provided to the LLM at time of inference, that is more efficient. And you're saying that Dante and Retune and others that use that methodology may be better than a custom GPT, which is probably, if you've seen when your custom GPT says, searching my knowledge,
yes,
it spends some time, the
it
little
does.
clock goes around. It's
Search.
looking at everything and
Yeah.
adding that to the context. That may be a little too much.
And
And
that's sorry, go
I'll
ahead.
tell you really quick, just a good actionable insight, actionable workaround for that is when you're building custom GPTs, I'll tell you two tricks. One, you need to put in your instructions, preferably the last instruction. So it's the first thing read, because there's a recency bias with the way instructions are read from the bottom up. One of the last things I'll typically put in is before you begin, I typically will call them tasks. So my instructions will typically have multiple tasks for the job I'm trying to do. And I'll say before you begin, before the user asks for its very first thing, whether it's I'm ready to begin or uploads a file, you need to go in to your knowledge base. And I want you to specifically hone in on these ideas and concepts. Basically, what I may be doing, although I've never thought of it this way, is I'm basically giving an example to say, this is how I want you to go look at the document before we begin. Because I have found multiple times, the reason I ended up doing that just out of trial and error was that I would often find that the answers did not go into the knowledge base and find what I was asking, and would give me back poor answers. When I changed my instructions from the get-go to say, you need to bring this in first before we start working together, I got much superior results. So that if anybody's doing this and they never really thought about vector embedding, but you're uploading knowledge docs, which is what it would be called inside a chat, custom GPTs, or just in a chat. If you're just uploading a document and you're like, can you help me summarize this document? Just like with everything with good prompting, the more specific and detailed you can be about what it is you hope to get out of it, the better your answer will actually be. And you can actually take that same approach towards what is going to happen with the vector embeddings to help hone the information that's doing. At least that's been my
I
experience.
I just thought of this now, and it was really interesting. Where whenever I've used ChatGPT and I uploaded a document, it for some odd reason it came out better when I said, review the document first, then I'll ask you a question. Versus me asking the question and then reviewing it. And I never kind of put it together until you just said it now. It's like, wait a minute. That's right. If it reviews it first and then stores that knowledge and then asks the question, it's already there versus I don't know why it does that, but it's a much better response than you asking and then it goes searches for it.
To me, it's like we're in multi dimensions, right? So to me, it's that Doctor Strange, to use your example, going in and preloading and saying, okay, I think this is where I should be before we begin. So he's gone in and done a whole bunch of this, right?
Yeah.
If you're not watching me, I'm just randomly grabbing in the air to multiple dimensions, but you just can't see it. But that's what's happening.
It's very cool.
Yeah, very well. Yeah.
He had 11 arms. It was amazing.
Yeah, very fast. StreamYard couldn't keep up with the high def though.
No, but you raise that's amazing, because that's right. If you've already gotten the information and then answered the question, it's much easier than you going out and having to find that information through everything that you've put in.
And a use case for this is literally at the end of this show, we're going to pull the transcript. The transcript is then going to be used in a custom GPT, as it is every day of the week. We do this, and that in turn becomes the summary that goes onto YouTube and is also used initially on Spotify, which then goes out to Apple Podcasts, right? So we need a summary of the show. What did we talk about, right? All the stuff we just talked about with vector embeddings. So now, not always, but now that custom GPT says, hey, when you get that transcript from the user, you need to go pre-read it. Then I want you to follow these directions to create this type of outline. The outline should look something like this, and I give it a one-shot example. That has consistently provided better results than if I was just to throw the document up and say, give me a show description of this. It'll do it. it's just not as good as when I tell it to go read it first, look at my example, now give me something back that looks something like this. So I'm using the best of both worlds. And back to your point, Beth, this is nothing new, right? Act as this idea of taking a lot of data and just trying to hone it in and narrow it in to get even better, more niche results. So this kind of works. Real quick, because I know we're almost at the end here, but I do want to mention most of what we've talked about today has been about text. But just so it's clear to anybody listening to this, it's not just text. Karl, you mentioned at the beginning, it could be images, video, audio. OpenAI has Whisper, right? So they can do transcription and stuff like that. That's vector embeddings. It can be entire documents, like you said. It could be people profiles when we talk about fraud prevention. I had people who were buying, I knew people this morning who were buying tickets to the Paris Olympics because I'm going to be over in Paris and hopefully going to some Olympic games. And because it was at 10 a.m., I had to wake up at 4 a.m. with my wife to try to get these new lot of tickets. And somebody said, oh, I bought 2 or 3, but my bank called me on the third one and said, hey, are you actually, is this you? Did you want all these tickets to the Olympics? Which, let me just tell you, they're not cheap. They're not cheap at all. Olympics has become a very expensive thing to go look at. Anyway, side note. But that's vector embeddings, right? Like that's using profile embeddings, and we know credit card companies have been using this towards fraud detection for many, many, many years. And so, just something to keep in mind as we're talking about it, business cases, probably more image, audio, video, mostly text is going to be our use case that make, for this show, but it can be used in many, many other places. Again, just putting a mathematical representation on that object, whatever that might be. And then it being in 1,500, what did you say? 15,000, 1,500 different dimensions.
1,536 for that particular embedding system.
Multiverses.
Which is
multiverse.
Not something you can,
there you go.
Yeah, it's a multiverse. Yeah, I think I love the Marvel explanation of that because it's coexisting in many places at once. So, all right. Do we have any other notes before we wrap this up?
Just really quickly, in the applied sense that you were talking about, Brian, vector databases require far less space for the amount of data it can store.
Right.
So that's one of the main reasons it's used for LLMs is because there's an immense amount of data. So if you have an application or your business has an immense amount of data, look at a vector database if you haven't already to contain all of that information.
Yeah.
Great point. Love it. Well, listen, tomorrow we have for our Friday show, first time we're trying this out. You guys can let us know what you think, but we're going to do a recap show. We're going to look back at our last 2 weeks of conversations, things that changed, ideas, things we went back and looked at after the fact. And that's going to be our show tomorrow. So, it's kind of the what did we just say type show. So that'll be tomorrow. Next week, we have a whole bunch of new topics. We're going to be talking about deepfakes. We're going to be talking about, can Swifties really enact new legislation? I honestly think they can. And it really drive us forward as far as AI. So that'll be interesting. I think we don't have it in there, but we're definitely going to have to talk about Google's Gemini Advanced, which just dropped today. So we'll maybe put a show in for that next week. But tomorrow, come back and hang out with us. We're going to be looking back at the last 2 weeks worth of shows and bringing our new insights and discussions to it. So that's it. And we will see you guys tomorrow. Thanks, Karl, for all the deep dive there.
Aloha.